Hello, welcome to part 3 of test preparation for test 18. We're going to talk about factoring. We learned 2 ways to factor. We learned to use greatest common factors to pull out what they all have in common, and then we learned to take trinomials and factor them into binomials. So let's look at the first example and remember how to do these. Here's a trinomial. The first thing that I notice in this trinomial is that I need to put all of my variables in descending order. I need the exponents to be descending. So I'm going to rewrite this trinomial and move them around. The highest exponent is 2. So I'm going to write my n squared first. The next exponent is this n to the 1 power. So I'm going to write minus 8n. And then the last one is this number 48. And remember, that's really n to the 0 power, which is 1. Now I have it in order, I can use our tricks. There is no coefficient in front of n squared. So I take this last number and I think, what multiplies to give me 48? Actually, negative 48. That means one has to be negative and one has to be positive. And what adds to give me this middle term, negative 8? Since my middle term is negative and I add to get a negative number, the larger factor of 48 is going to have to be negative. So negative 8 times positive 6 gives me negative 48, and then it adds to give me negative 8. So these are the 2 magic numbers, the factors that I'm going to use. I draw my parentheses so that I can write my binomials. The first term in each binomial is n, because the first term up here in the trinomial is n squared. I take the square root of that. The second number is going to be this minus 8 and this plus 6. I put minus 8 in one of these and plus 6 in the other. I have completely factored the trinomial into 2 binomials. It would have been fine if you had written n plus 6 first and n minus 8 second, because remember, when you multiply, they can go in either order. Now let's look at a new one. This trinomial looks bigger. It has coefficients for every variable. It does not begin with n squared, it begins with n cubed. So first I want to see if they have any common factors, any greatest common factor. What do they have in common? For numbers, they're all even numbers. So I have a factor of 2 that can be divided out of each one of those terms. In letters, they all have x's. The most x's that any term has is this x to the 1 power. So every term can be divided by an x. So 2x is my greatest common factor. Now I need to write down what 2x would be multiplied times in order to get this first trinomial. So I think 2x to the 3rd divided by 2x leaves x squared. 16x squared divided by 2x, that leaves 8x. And then 30x divided by 2x gives me 15. These are actually 3 factors that make this trinomial, but there's more. This trinomial in parentheses can be factored into 2 binomials. Now it's important to keep that 2 and that x out front, because my final answer has to be able to multiply to get my first trinomial. Now I'm going to look at this small trinomial, x squared plus 8x plus 15. I take this 15 and I think, what multiplies to give me 15 and adds to give me this middle term, 8, positive 8? Well, the factors that make 15 are 3 times 5, and yes, they add to be 8. So for my binomials, I begin by taking the square root of this x squared. They both begin with the letter x. Now for the second part of my binomials, I use these factors I found, positive 3 and positive 5. This is the first trinomial factored completely, and it would have been just as correct to switch those parentheses around as long as they're both positive the way I needed them to be. All right, let's look at another one. Here we have 3m plus 30m plus 48. M is not in every term, but there is a number in every term. So I need to find my greatest common factor. Do they have a factor in common? Well, 3 is divisible by 3. 30 is definitely divisible by 3. Is 48 divisible by 3? Well, the way you know is you add the digits, and if 12 is divisible by 3, then the whole number 48 is. And yes, 12 is divisible by 3, so 48 is divisible by 3. That means that I can divide a 3 out of that whole trinomial. 3m squared divided by 3 just leaves me m squared. 30m divided by 3 gives me 10m, and 48 divided by 3 gives me 16. Now I have 3 times a trinomial. I have to keep that 3, but I can take that trinomial and I can factor it into 2 binomials. What multiplies to give me positive 16 and adds to give me positive 10? Well, 4 times 4 makes 16, but 4 times 4 adds to be 8, so that's not right. 2 times 8 is 16, and 2 times 8 is 10, so that works. So I come back to my binomials. M squared is my first term. So for my binomials, they will begin with m, and they will end with these 2 factors, plus 2 and plus 8. This is the trinomial factored completely. All right, here are greatest common factors that are actually sums or differences. Now, here's a plus sign and here's a plus sign. So I have 3 terms separated by pluses. Each term has a z minus 5 in it. Each term does not have an x, and each term does not have a coefficient. But my greatest common factor is z minus 5. I can divide every term by z minus 5. The first term divided by z minus 5 is just x squared. The second term divided by z minus 5 leaves this 5 and this x, so I have 5x. It doesn't matter what order they're in. And this last term divided by z minus 5 leaves me 6. Now I need to keep this z minus 5 with my factors, but I can take this second trinomial and I can break it down into 2 binomials. Both binomials will begin with this x, but I don't know what the second part of those are. So I think to myself, what multiplies to give me 6 and adds to give me 5? Yes, it would be 2 times 3. That gives me 6, and 2 plus 3 gives me 5. So 2 and 3 are my magic numbers, plus 2 and plus 3. These are my factors. And again, those parentheses can be moved around. They can be in any order, but inside the parentheses has to be correct. Here's another one with sums of factors that are sums with these little parentheses inside. Let's see if we can find a greatest common factor because these look huge. Every one of these terms has this y plus 1, and every one of these terms has a m. They don't all have a 4 and they don't all have an x, but I found 2 common factors. So m and y plus 1 are common factors. Now I write down the other factor. The first term divided by m times y plus 1 leaves me x squared. The second term divided by all of that leaves me 4 and x. And the third term divided by this greatest common factor leaves me a 4, and that's all. The rest of it divided out. Now I have a simpler trinomial that I can factor into 2 binomials. I need to keep those greatest common factors written out front and create binomials with the others. They will both begin with x because the whole trinomial begins with this x squared. I need to find out what multiplies to give me this last term 4 and what adds to give me this middle term 4. Now that's odd. 1 times 4 is multiplies to give me 4, but it adds to give me 5, so that doesn't work. 2 times 2 multiplies to give me 4 and adds to give me 4. So 2 and 2 are the numbers I need in my binomials. All right, these are factoring trinomials completely. You will see these on the test. There are some in your book to practice if you haven't quite gotten the hang of it. Good luck.